check progress here. I'm going to take the derivative from this step. Power rule first. Bring the power down, raise that to 1 power less. Now I'm going to go inside the parentheses and do the quotient rule. We take bottom factor times the derivative of the top. That gives me a 2x minus the top factor times the derivative of the bottom. So I have x squared plus 3 times another 2x all over the bottom squared. So that doesn't fit. Let's go back.
So if you just pull out 2x and put stuff on bottom.
Can't get this to fit. What am I going to pull out?
2x is stuff on bottom.
I'm going to go ahead and multiply it out and see what adds out. And then I'm going to flip this over and make the exponent positive. It's got 1/2 there, and so we'll flip that over. So let's put the x squared minus 5 on top. X squared plus 3 on the bottom. That makes this now positive 1/2. And I multiply out in here. I'm going to have a 2x to the third minus 10x. And then another minus 2x to the third. And then minus 6x. All over that denominator squared, x squared minus 5 squared. So far, so good. So in the parentheses there, the 2x's add out and I get a negative 16x. This way. That's fine. I'm going to go a little bit further. What do you want me to do?
Something with the x squared minus 5, or
Okay, when you have like powers, you can subtract exponents. And then I'm going to take the 1/2 in here and make that a negative 8. So I get negative 8x alone on top. This is going to come down and cancel one of those. So I'm going to have an x squared plus 3 to the 1/2. 2 minus 1/2 is 1.5 or 3/2. So x squared minus 5 to the 3/2. Typically, what we want to do is get our derivative so it's in completely factored form. So it's already in factored form here, and this is also in factored form. Because we're going to be interested in doing things like finding where the derivative is 0. So either one of these would be fine with me. Were you able to get me somewhere near that? Yes, sir. I subtracted exponents because they're like factors. So 2 minus 1/2 is 1.5. And then I took half of the 16.
Okay.
And normal stuff over there.
Yeah. Why would it not be negative 3/2? Isn't that?
Because this is a bigger number.
It is.
Bigger
Negative
number.
3/2 on the top, looks at the bottom.
Yeah, can you like,
All right,
I don't know.
it's negative 3/2, but it's on the top.
Write it out.
And then the negative, you flip it to the next.
I'm having trouble.
Then it's positive on the
So you
denominator.
take,
Oh, okay.
so
So if you left it on top.
why do you subtract that? Because you subtract the bottom.
When you have like factors, you can cancel. So you can think of this as being, say, an x to the x squared minus 5 to the 1/2 times x squared minus 5 to the 3/2, and that cancels one of them. And I'm just using the property that a to the n over a to the m is either a to the n minus m or 1 over a to the m minus n. You have like factors you can cancel by subtracting exponents. Since the bigger one is on the bottom, I did this one. Yes, ma'am. Times x squared minus 5 to the negative 1/2. Then you're going to have a couple of separate terms. You're going to want to put them together as a single fraction. So that might give you more algebra to do later, but less algebra to do at the beginning. So
Wait, why would it be 3 halves instead of
2 minus a half.
4 2s minus 1 2? That's what it is. No, that's what it is. Yeah, okay. And then the half just reduce this to the negative 16.
Yep.
And everything else remain on bottom.
So how's the derivative? Derivative part okay? We'll get better at simplifying, I promise.
Why would they need to simplify it?
Because we want to find where the derivative is positive, where it's negative, where it's 0.
One x,
You know what?
all of those x's.
But how do you find the zeros? Right? You need things in factored form to find the zeros. Okay, so we're going to look more at the chain rule today, but more in a more abstract form. We're going to look at finding derivatives, not of functions, but we want to find a derivative if we start with an equation. We do something called implicit differentiation in section 3.6. And through implicit differentiation, we can learn how to take derivatives of exponential functions of other bases, inverse trig functions. So I'm going to derive some more derivative formulas. It's a pretty long section. We'll see how much we can get done today.
What's it called?
Implicit differentiation. So let me scoot this over to, what would that be? Would that be the west board? Nope, that's not the west board. That's the east board.
You said section 3.
3, 6. Just like that. There we go. I'll give you an equation, and I want you to tell me what is this equation of.
Circle.
It is a circle. Where's the center of this circle?
Oh, 1 negative 2.
1, negative 2.
That's not right.
So let's see. Got a center at 1, negative 2. And what's the radius?
Trace 3.
Radius is 3. So 1, 2, 3. It'll go through that point. 1, 2, 3. So I get a circle through here. What I got down there. Now, what if I wanted to know the slope of the tangent line back here when x is negative 1? What is the slope of the tangent line at x is negative 1? Or maybe I want to know the slope of the tangent line, somewhere else.
Can we take the top and half?
We need to get the derivative of the function, either that describes the top half of the circle or the bottom half of the circle. Do you know how you find the equation of the top half of the circle?
Is it just the positive squared? Something.
It'll be the positive square root of that. You'd have to subtract the x minus 1 squared. You'd have to take the square root of it, and then you'd have to add subtract 2, right? So I'm going to do that. I solve this for y. I get y plus 2 squared is equal to 9 minus x minus 1 squared. For the top half of the circle, I take the positive square root. And then I subtract the 2. So this is the equation for the top half.
Same exact thing.
Put a minus sign here if you want the bottom half. And then you would take the derivative. You would find the derivative. Let's go ahead and answer the question about getting the slope of the tangent line at x is equal to 1 by taking the derivative of the top half of the circle.
Top part, where'd you get the negative from for the bottom half?
Taking the negative square root.
Oh, okay.
Right? Bottom half is a negative square root, top half is a positive square root. So let's write the equation of the tangent line at x is -1, or at least get the slope of the tangent line at x is -1. So we need the derivative. And I'm using this equation, and I want you to think of that square root sign as a 1/2 power. So bring the power down, raise it to 1 power less, and let's multiply by the derivative inside. Eventually, we'll get out here and take the derivative. What's the derivative of the -2?
0.
Okay, so really let's just do the power rule over there. So we get 1/2 9 minus x minus 1 squared to the -1/2. And now we're inside the square root sign, taking the derivative of those two terms. So the derivative of 9 is 0. Now we're here. What do you get the derivative as for this part?
Is that another chain rule?
-2 x minus 1.
And then the derivative inside there is just 1, right? And so I'll simplify that. I'm going to take the half of the -2 and make that a -1. And then I'm going to put this term on the bottom with a positive power. Right there. Get the slope of the tangent line at x is equal to -1. Swap boards again. Nope, that's just in the middle. So I'm here, and I'm going to replace x with -1. I get y prime is minus -1 minus 1 over 9 minus -1 minus 1 squared. And then all of that is to the half power, so that's a square root. So let's see, I got a +2 on top. That's 2. 2 squared is 4. 9 minus 4 is 5. So I get 2 times 2 over the square root of 5. Now I want to do the same problem, but I want to take the derivative from here. When I take the derivative from here, I've got to remember that x is the independent variable and y is a function of x. So that when I take the derivative of the y term, I've got to use the chain rule, the derivative of y with respect to x. Here's what the function of x is for y, but I'm going to pretend that I don't know that. So here is another way to do it. We'll rub this off.
Oh, this is the implicit.
This is the implicit differentiation. In implicit differentiation, we start with an equation. Take the derivative of an equation by taking the derivative of the terms in an equation. As opposed to a function. In an equation, you're going to have the x's and y's together, as opposed to y on one side. Remember that x is the independent variable, so that when we take the derivative with respect to x, say of x to a power, you do it the usual way. It's the independent variable. But now y is the dependent variable. Y is a function of x. So when we take the derivative, for instance, of y to a power, or some function of y like we have in there, you do more than just bring the power down and raise it to 1 power less. The chain rule tells us now go inside and take the derivative of the y. That's prime instead of a 1.
You can also write that as like dy dx.
That's right. Like that is power y to the power minus 1 dy dx. This notation will come in more handy in subsequent sections when we take the derivative with respect to time.
Physics, you have to like cancel that stuff out. Crazy things.
Do crazy things that do make sense. Just have to keep working at it. Yes, sir.
When do we do, the opposite of it? What is it?
Antiderivatives,
Yes.
chapter 5. Chapter 5.
Is that our last chapter?
That's our last chapter.
I learned yesterday that we're doing Calc 2 second semester. I didn't know that.
What's that?
Or we doing Calc 1 first semester, Calc 2 second semester.
Yeah.
I didn't know that. So
I didn't know
yesterday-
that. That's why they're numbered.
It takes a while.
Guess when Cal 3 comes along?
The next semester, every semester.
Question?
Yes, so on the side where you took the derivative, all that fun stuff, was that just for the top half?
So I'm using this just for the top half because I saw in my picture that was on the top half.
And where did you get that top half?
I took this equation and I solved it for what?
That's
So
what you did
first
right
I
there.
solved for y plus 2 squared. Then I took the positive square root and moved the 2 over
And you moved one to positive because it's on.
because I want, my question was that x is -1 and I see that on my picture, that's on the top half of the circle.
So what was the problem? What were you trying to solve? No?
For this circle, find the slope of the tangent line when x is -1.
So what are we going back to the original equation for?
Because I want to show you another way to find the same slope
Oh,
without having to go through the solve the equation for y. We're going to get equations where it's going to be impossible to get the y by itself. Yes, sir.
So just to clarify, the top half was because x is bigger than.
That's right. If I was going to deal with, say, x is +1, I'd have to use this one,
we don't really care about that.
you know?
Well, right, because we're gonna try to do the other.
Well, you're going to see the other way is a lot shorter, and we don't have to do all that algebra.
I'll care about it.
You care about everything. You're a caring kind of guy.
Thank you.
Sir,
How did you pull? Actually, never mind, just answer my question.
You're crazy. You're such a good teacher with learning of yourselves.
what's wrong? Learning by yourselves, that's part of life.
You're such a good teacher when you learn about by yourself.
You learn everything by yourself. Drinking coffee. Okay, so here's the other way. We're going to start with the equation. And I'm going to take the derivative with respect to x of everything in this equation. Terms are separated by the plus sign. So I'm going to take the derivative with respect to x on the left-hand side. I'm going to take the derivative with respect to x on the right-hand side. X is the independent variable, y is the dependent variable. So here I have x explicitly written. I take the derivative by bringing the power down, raise it to 1 power less, multiplied by the derivative of what's inside. It's 2 times x minus 1 to the first power. The derivative inside is just 1. Now I'm over here. I can do it the same way. Bring the power down, raise that to 1 power less, and now multiply by the derivative of what's inside. This time the derivative of what's inside is not 1. The derivative of what's inside is dy dx, or y prime, whichever you prefer. Cross the equal sign, I take the derivative of 9, and I get 0. This gives me an equation that has the x, the y, and the y prime in it, and we're going to solve the equation for y prime. So I'm going to keep this term here, subtract that one. Then I'm going to divide by this stuff that's in front of the y prime term. And get dy dx is minus x minus 1 divided by 2. Oops, cancel the 2's. So now I'm going to evaluate that when x is negative 1. The only minor problem is I don't have the y value when x is minus 1. Go back and find it. Let's get the ordered pair over here. When x is negative 1, let's put that back in here and find what y is. So I'm going back to plug negative 1 in for x, and I'm going to solve for y. And I'm going to do it right in here. So minus 1 is a negative 2 squared plus y plus 2 squared is equal to 9. Square that and I get 4. Let's take 4 away from 9 and get 5. So y plus 2 squared is 5. I'm at the top half of the circle, so when I take the square root, I'm going to take the positive square root. And then I'm going to subtract 2. So square root of 5 minus 2 is the y value that corresponds to that x value. Now I'm going to find the slope when x is 1. So the slope of the tangent line at that ordered pair, x is negative 1, y is the square root of 5 minus 2. Plug that in here. I get a negative 2, we change the sign, so that gives me a 2. When I put the square root of 5 minus 2 here, and then add 2, I'm left with the square root of 5. And that's the same thing that we got before. We got it in that bit of space right there. So that'll help us later on when we have equations in which we can't explicitly solve for y. In 1 or 2 equations. Maybe we'll have too many y values in there. Maybe the y will be stuck inside of the trig function, things like that. Okay? So it's the chain rule. Y is a dependent variable. Anytime you take the derivative of an expression involving a y, take that derivative, that's the derivative of the outside, then you multiply by the derivative inside, which would have that y prime term on it.
So why did you come back over here to, so you were trying to find the y value?
Yeah, I've got
Plug back
x and
in.
y here. And I've got to get both of them to plug it in at that point.
And when you went back over here, you plugged in negative
Plug it
2?
in. No, I plugged in negative 1 for x. Right? X is negative 1. Negative 1 minus 1 is negative 2. And I'm solving for y.
This is order pair for that. Oh, that's just the.
That's the ordered pair that I'm finding, the slope of the tangent line at that ordered pair. Okay, so let me give you another equation here. Let's see, let's put it right here. For all of these, find derivative of y with respect to x. using implicit differentiation. First equation. Let's have 3x to the negative 2 plus the square root of y minus e to the y is equal to 1 over x. So notice that if I gave you this equation and said, solve this equation for y in terms of x, you couldn't do it. Because there's one here, there's one there, and that one's even in the exponent. But it does describe some sort of graph in the xy plane, so it does have things on it that would have slopes. All right, so the implicit differentiation part says, just take the derivative of each term with respect to x. And when you take the derivative of y to a power, bring the power down, raise it to 1 power less, take the derivative inside. When you take the derivative of either y, you get itself times the derivative of the power. Okay? All right, so here we go. I'm going to put this part down. I'm not going to write this the next time. I'm going to take the derivative with respect to x of each term. I'm going to go ahead and write that as y to the 1/2. The terms are separated by the plus and minus signs and the equal sign. This is two-handed. That's what we're going to do right there. So I set them up so I can use power rules. When we take the derivative here, we bring the -2 times the 3, gets me -6. 1 power less is -3. The next term, I get 1/2 y to the -1/2. And now I have to remind myself that y is not an independent variable, it's the dependent variable. So I go inside here, take the derivative of it, and I get my y prime term. Same deal here. When I take the derivative of either y, the derivative of e to a power is itself times the derivative of the power. And then on the right-hand side, the derivative of x to the -1 is minus x to the -2. You okay with that?
So when you just take the derivative of like a y variable, that's where you're getting dy over dx.
That's right. That's the chain rule.
So on like assignments or something, would you care if we put y prime or?
Yeah, I'll go back and forth and I'll do them either way.
Okay.
I just thought it was Keaton and insisted that I use dy over dx, so I did. He bullied me into using it.
Right.
Oh, y prime kind of gal.
Me too.
You're a y prime kind of gal? All right, now we get an equation. In this equation, we go to solve it for y prime. So I'm going to keep the y prime terms on the left-hand side of the equal sign. Keep these two guys together, and I'm going to move that term to the other side. So I'm going to write this as, can I write that as 1 over 2 squared y? Was that going to bother anybody? That bothered you? You go back and leave it at 1/2 y to the negative 1/2. I'll leave these with negative exponents. That way we compromise. I'm going to add that to the other side. Like that. We isolate the y prime term so that I have a common factor of y prime. I have other common factors, I don't care, but if I pull out my y prime term here, I can solve for it in the next step. So pull out the common factor. And then in the next step, we get the y prime all by itself by dividing by what's in those parentheses. And that was my goal, to get y prime. So now if I needed to know the slope anywhere, I can just put numbers in for the x and the y.
Aren't there two notations for the derivative? Because like Newton and Leibniz found it at the same time and both used different notations. I think that one is Leibniz notation and the one used before is Newtonian. We use y prime, Leibniz is d by dx.
I'll have to,
Or you know.
I don't know that off the top of my head, but it sounds like it should be true. So by gosh, let's make it true.
Pretty sure it is.
Everybody okay with that?
Well,
Okay. Let's get another one.
or Newtonian.
Second equation. Same instructions. This time my first term looks like 6x squared y cubed. Next term plus the tangent of y. And on the right-hand side equals the sine of x. So again, our terms are separated by plus and minus signs. Why would that be west?
It's crazy they couldn't think of left and right.
So which is left, which is right?
Left, right.
Yeah,
right.
exactly.
They say it's west.
I got a west and an east.
Oh, what's the never changes?
I guess there's a reason this is the map.
Okay, what do you see in that very first term? You see a product rule? I've got an x squared times a y cubed. So by gosh, that's a good eye. We are going to do the product rule here.
Can you pull out the 6 first?
Don't need to, but you can.
Yeah, lazy.
I'm going to treat that as my first term. And that one's my second. The first times the derivative of the second plus the second times the derivative of the first. Okay, so you're going to help me. I'm going to copy down the first term. So I'm skipping this step. I'm doing that step in my head where I'm taking the derivative of each term. That was just extra writing anyway. So I'm doing the product rule. The first term is 6x squared. Now I need your help. What's the derivative of y to the third power?
3y squared y prime.
3y squared y prime. All right, let's use the prime notation this time. Now the other way. Second term times the derivative of the first. That's just 12x. Now we have the plus sign. And I need somebody to take the derivative of the tangent of y.
Secant squared y prime.
Secant squared of y times y prime. After you finish the derivative of the outside, multiply by the derivative of the inside. Then on the right-hand side, the derivative sine of x is cosine of x. So let me isolate the y prime terms. This guy and that guy have the y prime, so they're going to stay on the left-hand side. I'm going to move this to the other side by subtracting it. And I'm going to get rid of the parentheses by writing that as 12xy cubed. What I'm leaving over here, I'm going to simplify this as 18x squared y prime, 18x squared y prime. I'm going to write that next plus secant of y prime. And then on the right-hand side, I have the cosine of x. And then I'm subtracting this one, which I said I was going to write as 12xy cubed. So minus 12xy cubed. Get the y prime terms together, the non-y prime terms on the other side of the equal sign. So that the next step is factoring out the y prime. Put that out front. And we'll have 18x squared y squared plus the secant of y, all times that y prime that I pulled out front. And then in here, cosine of x minus 12xy cubed. Yes. Where did I get the secant squared? I took the derivative tangent. You waited a long time to tell me that, didn't you? Secant squared is the derivative of tangent. Let's make those secant squareds everywhere. And then the last step is to divide by the stuff in the parentheses. So here's our final expression for the derivative. Y prime is cosine of x minus 12xy cubed, all divided by 18x squared y squared plus the secant squared of y. You know, if I need to go back and show you anything.
Actually, you did Lagrange, or Leibniz and Lagrange. Lagrange did f prime, and Leibniz did dy dx. You can put like bullet points over the x's.
The dot notation,
That's good.
that usually stands for derivative with respect to time. Sometimes you see it written like this. Okay, I'm going to go back to, let's say, the east board. Zoom. Let's do another one. Okay, same instructions, equation number 3. Let's see, let's go with x times the cosine of 4y. There's your another product rule. I said x times the cosine of 4y minus y to the 5th is equal to 12 minus y.
We know cosine before y.
Chain rule. Take the derivative outside times the derivative inside. So you do the first line, do the product rule on it first term.
What's the rule we know? Is it cosine 2x or is it 2 cosine x? Where it's
Oh, the
sine-
identity?
Yeah.
Yeah, well, that's a double angle formula. So here you're gonna do the product rule. And the rest are just individual terms. In fact, I'll do my part. I'm gonna take the derivative of 12.
Save.
Now, I've left you the other ones.
No, it's equal to not the derivative of. That's what I was saying.
Which gooder? Let's do that first line where you take the derivative, and I'll check it with you, and then we'll solve for the dy dx or the y prime, whichever you choose. Let's see what your book uses. The book uses a dy dx.
So when you're using the product rule and your y value is in either the first or the second term, you're taking the derivative and you're still using the chain rule with respect to wherever the y is.
Correct.
To find the derivative of y. Right.
That's where it appears after you take the derivative of the inside.
Yes.
So after you take the derivative of that cosine of 4y, you're going to get a 4y prime inside.
And then you continue the product.
Yep. All right, so make sure you got this part right. Here's the product rule. X is the first, then the second is cosine. The cosine is a minus the sine of 4y. Now I'm inside here, and I get a 4 times y prime. So that's half the product rule. So now the other half, copy down the cosine of 4y, and multiply by the derivative of the first, and that's just 1. Okay, now I've got the minus y to the 5th, so its derivative is what? 5y to the 4th y prime. Here's the part that I did already. 312 is 0. What about the derivative of the y on the very end? So we've got y primes all over the place. These two y prime terms have minus signs in front of them. So how about we take those and move them to the right-hand side? Let's add those over to the other side. And leave the cosine of 4y there.
Is it necessary for you to do 0 minus y prime?
No,
to
I just felt like I was participating by doing that.
But just to signify that you took the derivative of both.
Yeah.
Okay.
Okay, so this is the same as minus 4x sine 4y y prime. So when I put it over here, it becomes a positive 4x sine of 4y times y prime. So I put this 4 with the minus sign with the x together, then I added it to the other side. I'm going to add this to the other side, so plus 5y to the 4th y prime, and this guy's already over there, minus y prime. Once you get the y prime terms together, you factor out the y prime. And here I'll have 4x sine of 4y, factored that out. Over here, what's left is 5y to the 4th. What's left when I pull this y prime out? Minus 4. Now divide by the stuff in the parentheses, then we have our y prime. Cosine of 4y will be divided by 4x sine of 4y plus 5y to the 4th minus 1 is our y prime. Turn it off, put it in the big cloud.
So one of your last steps is always going to be to factor out the y prime and then divide from the other side.
Divide by whatever the y prime was multiplied with. Okay, so let's use this to write an equation of a tangent line in the next problem. I'll give you an easier looking at expression. Let's write an equation of the tangent line. To x squared minus 4xy plus y cubed is equal to 6 at the point where x is 5 and y is 1.
We have to find the y.
That was. So your first step is to generate the equation with y prime in it. But we can kind of skip these steps. Let's get to this step and then put the numbers in. It might make it easier to solve for y prime. Take the derivative of each term, and then we'll put the numbers in. Be careful right here. What do you see right here in the middle?
Products.
Product rule, but be careful, this is going to have a minus sign, so don't lose it. So I'll give you, let you try it by yourselves, carefully. Don't burn your hands or anything.
6.
It's the end of the coffee. A bit more.
So here we're finding
Here we're finding you're going to go through there and take the derivative, get the equation that has the y prime in it. You ready to check it? Once you get the equation that has the y prime in it, go ahead and put in the 5 for x and the 1 for y, and then see if it's easier to solve for the y prime. So your tangent line. 14 over 17?
Yeah, that's probably the one.
Oh, we got a negative 20 over 21. How much you got? 10 over 73. No two answers should match. Pick your favorite number to use for your tangent line. We can start, we put a little wager. We can vote on a number and then whoever wins it gets all the money. Like that?
As long as I'm not that much.
Oh, well, that takes the fun out of it. We just use pretend money.
Yeah, that's good.
I got 6 over 17.
6 over 17, yet another slope.
I got 6 over 7.
Uh-oh, this row got 6 over
I got 6 over
17.
17.
And move into
I think
this
they
row.
all cheated off of me. at the same time.
Okay, we're gonna see where the 6 over 17 came from because that wins by popularity.
Yeah.
Now let's do calculus and see what wins by calculus. What'd you get as the derivative of x squared?
2x.
2x. Okay, now you've got this minus sign here. I'm gonna put it there, and now I'm gonna do the product rule, where this is my first term, and that's the second. So I'm gonna leave the minus sign behind. So it's the first times the derivative of the second. What'd you use the derivative of the second? Plus the second times the derivative of the first. Okay? Now moving down to the y to the third, and we get 3y squared y prime. And then the derivative of 6.
0.
Okay, now I'm gonna, with my eraser, distribute that minus sign. So I'm just gonna erase the parentheses and change the sign in the middle. That one's minus, that one's minus, and that one's minus. There are 2 terms that have the y prime. Let's leave those on the left. Oh, I said let's plug the numbers in. Let's do that now. Replace x with 5 and y with 1. So we have 2 times 5 minus 4 times 5 times y prime minus 4 times 1 plus 3 times 1 squared times y prime is 0. So that's 10 minus 20y prime minus 4 plus 3y prime is equal to 0. So let's add our like terms. This is going to give us a negative 17 y prime. That's my board. There, up here. So when I say negative 17 y prime, and then this becomes a positive 6. I'm going to subtract that to the other side and put a negative 6 over here. And then divide by the negative 17. The negative over a negative gives us a positive. That's the slope of the tangent line. Is that what you guys had in that row? Hoorah. This minus sign. Now I've got the point and the slope. The last step is to get this equation. Y minus y1 is mx minus x1. So y minus 1 is 6 over 17 x minus. If you have an expression for y prime in terms of x and y, how do you think you find y double prime? Do it again. The derivative of y prime is y double prime. And then you'll take the derivative of the other side again. So let's find the second derivative. Let's get an easier equation. Let's do the second derivative on the list board. All right, you silly thing, I punched you. There it is. But let's do kind of an easy equation. Let's go with, let's start with this equation. X squared minus 2y to the 4th is equal to 10. X squared minus 2y to the 4th is equal to 10. I want you to find y prime and y double prime in terms of x and y. So y prime's a quickie. Give me the equation for y prime, and then I'll get the second derivative with you. Stop once you get y prime, and I'll pick it up from there with you. All right, ready for me? Derivative of x squared is 2x. The derivative of 2y to the 4th with the minus sign in front gives me 8y to the 3rd times y prime. And then the derivative of 10 gives us 0. It's okay? Keep going. Let's solve for y prime. So let's just, doesn't matter what you do. Did you move the 2? And we divide by the negative 8y cubed. And then we simplify. Y prime, the negatives cancel. 2 goes into 8 4 times. So how about x over 4y cubed? Is that what you got? Anybody? Okay, so now y prime is the same as dy dx. So if I take the derivative of y prime with respect to x, I get y double prime. If I use this notation, that means I'm taking the derivative with respect to x of dy dx, which gives us a d squared y over a dx. But instead of the dx all squared, we just write it like that. So if you do the second derivative using the dy over dx notation, this is how we label it. If you want primes, you just keep slapping on primes.
One thing, why do you not write it?
With this, takes too long,
That's-
right?
But why is it d squared y?
Because there's a d and there's a d,
Derivative with respect to y.
right? So that makes two d's, but one y. There's a dx, there's a dx, so there's two dx's. We don't put the parentheses because we treat the dx as one entity. All right, but I'll use the y double prime since I started with y prime. So we've got an equation. We take the derivative of both sides of the equation. So when I take the derivative over here, that's where the y double prime comes from. The right-hand side is a fraction, so I'm going to do the quotient rule. I'm going to do the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. So here we go. The bottom is 4y cubed. Now I'm multiplied by the derivative of the top. And what do you get as the derivative of the top?
1.
I'm not going to write the 1. Now minus the top times the derivative of the bottom. Here it's your turn again. 12y squared y prime.
Cancel before. This one simplifies nicely.
All over the bottom squared, so we have 4y cubed all squared. So I can simplify that just a nudge more. Y double prime is equal to 4y cubed. Let's write this as minus 12x y squared y prime. All over, now let's do the squaring. 16 y to what power?
6.
Good.
And you can cancel y's and 4's.
Okay, I'm not gonna do that yet because my instructions were to find y double prime in terms of x and y. And I've got y double prime in terms of x and y prime. So we gotta get the y prime out of there. We're gonna put that in where the y prime is. So I'm gonna circle that. This is coming out. This is going in. And I'm gonna have to move over here to this board and hit switch. So I'm moving over to the other board with my magic button that I can't see. There it is. So I've got y double prime is equal to 4y cubed minus 12xy squared. In here, I'm going to put the y prime that I got from the first step. That's going to be x over 4y cubed. All of that is divided by 16y to the 6th. Okay with that? Now I'll take your answer there, but I'm going to simplify because I've got like not enough time to do a whole problem, but too much time to let you out early. What? I was going to feed you, but now I'm not. 4 goes into 12 3 times. This y squared knocks out 2 of those, so that's a y to the first. That x multiplies with that x. So we have 4y cubed minus 3x squared over y divided by 16y to the 6th. That's just canceling common factors from the top to the bottom. If I don't want that y in my numerator in the denominator, how can I get rid of it real quickly? multiply top and bottom of this fraction by y. I like to see all those fractions within a fraction. And so we can get it down to this. I'll have to multiply that y by the y outside, so I have a 4y to the 4th minus 3x squared. The y cancels over there. Downstairs, we're gonna have 16y to the 7th.
So pretty.
Isn't it pretty? It's pretty enough that if we wanted to,
Third
we could find a
derivative.
third derivative, right? Find a third derivative of that pretty easily. Any questions on what we did here? Okay, so there's a bit that I haven't covered yet using the inverse trig functions. And then there's also something called logarithmic differentiation. So we're about halfway through section 3.6. We'll finish it up on Friday.
Where'd you just say that?
And I've got 3 papers up here. Hey, Cash, Hannah, and Heidi. Please come pick up your paper. And everybody else check to make sure that I'm current with what you've submitted. Make sure that I've entered everything on Blackboard. If not, I have to go digging through my email and see where it's hidden. That's okay. Yeah, sure, absolutely. Sure, no problem. I'm gonna keep recording.
We don't know yet, but like, yeah, I could probably do it.
Okay, well, whatever works best for you.
Is the advanced math class the one that starts with a 3 or the one that starts with 2?
Which one is that?